If heat rises, and every science teacher alive will confirm that it does, then the highest points on Earth should be the warmest. Everest sits nearly 6 miles above sea level, closer to the sun, surrounded by rising warm air from below. Yet it sits under permanent snow and ice cold enough to kill an unprepared climber within hours. Meanwhile, the Sahara Desert, flat, low, far below Everest, bakes at over 50 degrees Celsius. Something in that basic equation doesn't add up, and the official explanation quietly contradicts itself in ways nobody talks about in school. Science says the atmosphere gets colder as you gain altitude because air pressure drops. Less dense air holds less heat. Simple enough. But wait, heat rises. That's not a theory. That's observable, testable, everyday physics. Hot air balloons work because of it. Smoke goes up, steam goes up, warm air goes up. If warm air rises continuously, why is the top of the atmosphere the coldest place rather than the warmest? The heat went up. It should have arrived somewhere. So let's talk about the layers of the atmosphere and, some alternative ways of looking at things. The atmosphere isn't just a single layer. It's made up of several, each with its own temperature and characteristics. But here's the thing. If heat rises, as we've just said, then why do we find that the highest layers are actually freezing cold? Some folks have proposed different models to explain this, but honestly, it still leaves us wondering, doesn't it? How does all that rising heat just seem to disappear? The explanation for cold mountains contradicts the explanation for why heat rises in the first place. Both can't be fully true simultaneously, but both get taught as settled fact. And here's where it gets genuinely strange. The stratosphere, sitting above where we live, is actually warmer than the layer directly below it. Temperature increases again higher up, then drops, then rises again in the thermosphere to thousands of degrees. Not a simple gradient, not heat rising evenly to a warm top, a layered, inconsistent temperature profile that switches direction multiple times as you ascend. That pattern doesn't match a simple rising heat model on a ball. It matches something else entirely. On a flat plane with a dome above, atmospheric temperature layers are produced by the dome structure and the local sun above, not by altitude on a spinning ball. The sun heats the surface directly beneath it. Air near the surface absorbs that surface heat. Higher layers receive less direct surface warming and less dome-reflected energy, so they're colder. Mountains are cold because they extend into air that receives less surface heat transfer, not because physics contradicts itself. If the snow on Everest just made science class feel inconsistent, follow this page.